we will demonstrate requirements import from doors, requirements update from doors to SysML model, linking to the system model, and impact of requirements change, and how this is managed with capabilities of comparison when we get new requirements from doors, and with the suspect links traditional requirements management capability for impact analysis. So first of all, we will use Cameo Systems Modeler plugin Data Hub to import its native plugin to import requirements from doors traditional doors 9.6. So I will go to the Tools Data Hub Explorer. I will browse doors database and will create and will drag and drop a couple of the specifications. So we'll choose system requirements, drag and drop it here. Okay. And based on that, by default, available mapping requirements elements are created with all the properties and relations if those are available in doors. If we importing specifications one by one, as it is right now, once the second specification, which is traced to that existing one, is imported, the traceability will appear. So we see the percentage going, right? We have now everything imported. We have a lot of messages which confirms that data got imported. And now I can visualize this data in requirements, standard requirements table. Let me check the scope here. I have those requirements here. Now I don't see any relations, but if I will import another specification, this kind of stakeholder needs now into another package, I will get relations because they are linked between. So we can see here in doors, system requirements are traced from the stakeholder needs, right? So I can now discover the same traceability also when I'm importing. And again, I'm importing piece by piece. I'm not importing everything at once. This gives me flexibility when the data needs to come in and separate synchronization scopes and other things. This is additional traceability. Now I see here the links are identified that they are not mapped, and I can choose what relation to use. So for example, derive requirement relation. And for this one, also derive. And selected solution can be made as the default on the import. I can choose the import direction that the data from doors would come into the Cameo Systems Modeler one way, or both ways changes would go. And now it is both ways. I can choose that one way to magic draw only, and I get the data in. So I can check status, everything was synchronized, close. Now I see I got stakeholder needs, and I see also trace relations, and also here relations, right? So now I can visualize them in the again standard table. I have now stakeholder needs and system requirements, and I will set the scope. Here my stakeholder needs, and I can check that I can see some duplication between IDs. And this is pretty much whatever I got from doors. I got IDs. I can ignore that. In normal case, I might not have duplicated IDs if doors are managing them correctly. Now I will show the column which will show me the the traceability. Or I can create the out of the box derive requirements matrix, and will be requirements here and requirements here. Refresh. So I have stakeholder needs here, and I have system requirements deriving from stakeholder needs. So traceability went through from the doors. And based on that traceability, we will check the impact of changes. One thing what we see immediately, that the elements which were imported became blue. If I on the import, I will see that every time anything got updated, I will see that in blue. If I click save, color will change. It means that now we see this as the regular color of the elements. And if this, is working in the repository, I also see every change which was done in this project after it was checked out from the repository. Now let's create some small model here, and let's, for example, model this Bluetooth headphone system and trace to some of the requirements. So let's do collapse. I will create another package. Let's take the naming 3.1 system structure. And I will create block diagram. We'll create phones. Can create some parts. Audio subsystem. Power management subsystem, and then housing can layout, and I can introduce more space here, and I can model characteristics. So for example, values will be operating time, and this can be integer as a property, or can use some existing properties. So for example, I can use time second. I have this piece of model. I can even specify the value here. Let's say that it is 4 hours, right? And then you see this unit appears as the default value. And then I can link to requirements because those requirements should be satisfied. So I can go here and performance, operating time, and pretty much all those requirements, they could be modeled. Shall provide 4 hours of the performance, and we can see here this property satisfies this requirement. Now, if I will change something, like this requirement is tracing to stakeholder needs, model tracing to system requirements, and system requirements it's tracing to stakeholder needs, I can visualize this traceability to see whole impact. So I can go here, select requirement, display related elements, traceability here. So battery shall last long enough to see full 2 movies, and it's 4 hours in the system requirements. So the stakeholder needs, I can navigate to those stakeholder needs here, and this comes from the system requirements. I can navigate again to the system requirements, right? And this model satisfies this. So now I could get a change. Let's introduce some change. Let's say that I will introduce change on the system requirement level. And this change will happen on stakeholder level, and this change will happen in the door. So I will go to my doors model, system requirements. Here is operation time. And let's say that someone said that, okay, it should be 5 hours on system requirements. Save. And now we see that this is different, right? Now here in the Data Hub, there is capability to check for changes. Before synchronization, you can always check for changes. And Data Hub, this integration framework to doors and many other tools, gives the ability to keep in sync model and requirements proxies in the model and requirement source in the doors. Now let's select the scope. I can choose any scope here, let's say system requirements, and say check for changes recursively. So I see that one requirement is changed. I can select this requirement. I see it's modified. I can select see the properties. So I see here that it's 5 hours here on the doors, and here I see 4 hours. This text is object text in doors. It's text and requirement. I can suppress this now. And this is doors database, this is magic draw database. Now I can select that I will update from the doors to magic draw and click synchronize. I see here new entries, modified, moved, deleted, out of scope, and excluded elements. Everything is here. Now it says that synchronization will be performed on this single item. Yes. And synchronization is done, right? So we see that it's successful. Now, first indication that something got updated is that this element becomes blue, right? But this is something which we just see visually, right? On the commit to Teamwork Cloud repository, we will also see that this element got modified, right? But for example, we don't see that as impact on the system model, right? Even the system satisfies requirement, this impact is not visible here, right? So for that purpose, there is additional capability between, we saw first capability was comparison between resources in model and the requirements. Another capability is suspect links. So we will enable tracking of suspect links through analysis suspect links. And this capability, I will say that, okay, let's do entire model. This capability on requirement change will map all the related elements to requirement as a suspect, but only through the few selected relations. So derive between requirements, satisfy between a model which shall fulfill this requirement and requirement, verify it's between the test case and requirement, and refine between model which explains requirement in more details and requirements itself. Containment relation is not treated as a suspect because it is just like containment as part of that grouping of requirements, but not necessarily the logic is impacted. Suspect does not mean that you need to do something but to update requirement, but you need to review it and confirm that it is no longer suspect. Now we start tracking the suspect. I can always go here, analyze suspect links, and show suspicious. So show suspicious, there is no suspect changes. Right now, let's go back to the full to movies, full free movies. Save it. And now let's go back here, right click, stakeholder needs, click, check for changes recursively. I get this change. I can check what is that change here. Yeah, here is the change, full free movies, right? And here is full 2 movies. Now I will select this one or whole model and synchronize. So yes, do synchronization. Once you did synchronization, so you might be the one who works on requirements and you are not the one who knows the model, but you're the one who pushed the requirements in. And now we can check the impact of those changes. So let's go to save this model, right? And then someone else comes and see, okay, I know the new version is available on server of the model. I want to check the changes. So go to suspect links, show suspicious, and it get impacted. So you see that everywhere in the model, it gets impacted, visualized. So it's just like direct relation to that changed requirement. I can see even directly what was modified, which property, how was modified. And I see those same information in the table. You see here that it is the linked element was modified. It identifies everywhere. Now, once I'm done with the update, so for example, a full charge battery shall provide maybe 3 movies, should be not 5, maybe it should be like 6 hours of continuous operating, then audio from a Bluetooth source. And then I can select this requirement, right? Select it here, click on the suspect links indicator and clear suspicious. Once I clear, it clears everywhere. It's no longer marked as a suspect. If I will select it now, save it. Now let's imagine that we have those links here from here to here to here. Now someone comes from the model side who works on the system model, and he wants to see impact of the system requirement change on the model. So previously we checked impact of stakeholder needs change on the system requirements. Now I will go to do the same. Analyze suspect links, show suspicious, and I see that impact. I see that impact everywhere. I see impact in the diagram. Let's minimize it. I see impact on directly on the property. You see the yellow. I see impact here. I see impact even at the top level here. But this is gray icon. This gray icon means that in containment, in the child of this package, the element of this package, the element of this block, this is the element which is suspect. I can do the same then, select and clear suspicious. But before doing this, I might update the value here to 6, right? And then select and clear suspicious. So now no longer suspect. So that's how we can do impact of the change. And this is very precise based on those few relations which are derived requirement, which is between the requirements. Here we see it. Then satisfy between the elements of the model which fulfills requirement, satisfies requirement. Then verify between test case and requirement, and refine between any element which explains requirement in more details, like use case. So that's the suspect links capability. One more on the change impact analysis. And in the case of repository, it also involves ability to compare two versions and ability to see automatically what was changed in the requirement. Now let's do one more thing. Let's turn on automatic requirements text analysis. And this is an independent capability of the simulation, because sometimes we just want to perform, let's switch back the look and feel. Let's go to tools, options, project option, and general requirements term glossary, turn it on. And then let's imagine that the text would be based on then specific patterns. So a full charge battery shall battery shall give shall be 6 hours of continuous operation when playing from a Bluetooth source. And you see this text got underlined. So this is converting this requirement text to automatic constraint, which is not available in the model, but it's runtime. And the name of the property which satisfies this requirement becomes as the one which shall be at least Now we see that it converts to that at least more or 6. And what are the patterns used? So we see this glossary with all the patterns. And this is the way to increase the quality of requirements. We can use this glossary, which is customizable. And when we write requirements, constraints are automatically extracted and used in the model to constraint requirements. So now if in any way this parameter value is analyzed and calculated automatically during the simulation or during any analysis, we will get this property green or red, and we will see which requirement is satisfied based on this automatically extracted constraint here. So let's say I will put by accident 7, that's okay. If I will put 5, it's no longer good, is not satisfied. So this configuration is not satisfied. And this is parametric analysis. All those properties can be connected to other properties. They can be a result of the roll-ups, mass roll-ups, power use roll-ups, and some analysis model externally coming to this model. Or just by the testing, we can just input the value here during the test and see which requirements are satisfied, which not. This part is automated requirements verification. It's available as a separate webinar. You can find it on nomagic.com. Events, webinars. The last part of this. Let me jump a little bit. Even more. And here we see automated requirements verification. That's the webinar which introduced this capability with 1-hour demonstration on the parametric analysis and requirements change. Plus this automatic natural language analysis, which is available out of the box with newest versions of Cameo. It was not available at that time when we required constraints to check any requirements, formalization of requirements. Now it is automatic if we are using this glossary and we are typing text based according to the glossary and converting requirements automatically to constraints. So thank you for watching. That was the overview of requirements synchronization from doors as a proxies to model in order to continue with the modeling during the system engineering and requirements change and impact analysis. And this capability is used, those capabilities together with Data Hub are used very widely. This is the most popular integration used by all the defense contractors, pretty much as the doors traditional is the standard requirements management tool. Thank you very much.